Problem 36 states, given a B tree with a max degree of 3 and a min degree of 1, as well as the following insertions and deletions, select the final B tree. So first, with a max degree of 3, that means we can contain 2 values and have at most 3 child nodes in any given B tree node. So the first step is just take the first 2 and put them in sorted order. When we do 22, 22 would be outside, which means we're going to split in the middle, which in this case is 15. So what we're going to see is we're going to see a node created for 7, and that's going to become the first child of 15, and then the second child of 15 will be 22. Next, we're going to insert 26, and then we're going to insert 24. 24 would be in the middle, and it would split and raise at 22 and 26. But because we have an empty node here, what we're going to see is that 24 is going to go into that empty spot. So I am going to put 24 here in the middle, the second element, then 22, and then 26. Then we're going to have 17 here. We'll have 4 on the left, and then we put in 21. 21 would split and rise, which brings us actually here. So 21 would split and rise again. So what's going to happen is, in the final tree, what we're going to have is, I'm going to write down here on the bottom, we're going to have 21, and it's going to have 15 and 24. The way this is going to split is because 21 was initially between 17 and 22, we're going to have 4 and 7 here on the left, and the second child of 15 is going to be 17. Now 24 is going to have 22 and then 26. So this is the new tree after all of the insertions. So the first one is going to be 21. So on the type exam, you're going to see that it's highly likely that one of the deletions will be a root node, and then a second deletion will require a merge and so let's take a look at the first deletion. First, I would get rid of 21 and then take the largest value on the left and move it up. So now we have an empty node here. If we have a way in which we can borrow from the previous, if it's on the right, or borrow from the next, it's on the left, then we need to fill it. And so the way we do that with a rotation, so we'd have 4, we would move 15 down and have 7 up. So 7 is here, then 15 is down. The second deletion is going to be 24. So initially we get rid of 24, and we do that, we can move 22 up. So we see that we have an empty node here. Since we don't have enough nodes to fill all of these elements, we have to do a merge and then raise the empty node. So in this case, we are going to merge 22 and 26, like so. And when we raise it, what we're going to see is that we once again have another situation where we have 7, 17, and an empty node. And because we don't have enough values to fill, we have to again do a merge. So let's do the merge here. And what that is going to do is we are going to have 7 and 17 in the same B tree node. And we are going to put 17 in the second value. And then its third value node here goes to 22 and say, so the third node pointer. And initially what would happen is the empty value would be here. And that's pointed to by the root. And so the root, what we would do is we would just erase that, and that becomes our final B tree. And this matches choice B, so therefore the answer is B.